All right, so let's look at the notes for 8.4. Remember, the focus of this was on how parallel lines can create similar figures. And that's what you would have seen in the task, is that parallel lines make overlapping triangles. So if you look at this image here, if we have these three parallel lines, and they're cut by transversals, they can create these overlapping similar triangles. Again, similar meaning the mathematical definition of proportional side lengths and congruent angles. Notice there that it's not like this is triangle and then this part, it's the whole thing. So if I highlight them, so like here's the one smallest triangle. And then if I highlight this larger one, again starting from the same point up here, that pink one is kind of overlapping with the green one, and so that's where we see the similar triangles. And then you can even see the larger one here if I highlight in orange, again starting from that top point up there. And so with those overlapping triangles, and again, it doesn't have to be triangles, it could be a different shape. We'll often look at it in terms of triangles, but it could be a different shape, is that the corresponding sides are proportional. So like in this case, the length of A plus or over the length of A plus C, which would be the total length of the pink triangle here, is equal to the length of B over the total length of B plus D, whatever those lengths are. So again, it's the same thing that we have been doing, but just recognizing that there are the small triangle here, and then the large triangle is these two added together. It's not just the length of C. But also with this, the corresponding parts are proportional, meaning that A is over B, the ratio of A to B should be the same length as C to D. So even though C and D are not part of the whole triangle, the ratio of the parts of the segments there it should be the same if we have parallel lines forming these similar figures. So let's look at some examples of this type of idea. So in number one, we're told that the triangles GCD is similar to GFB, which is similar to the triangle GAE. You can see all of those in the figure here. And so we'll complete their proportions. Okay, we'll complete the proportions over here. So we know that these are all similar triangles, and we want to just complete the proportions. So we kind of are matching up the corresponding sides here. Make sure we understand that. So here we see GC, looking here, GC is corresponding to GC, the relationship between GC over CF, and then something over DB. Okay? Well, remember that the sides are, the different parts are proportional to each other. Okay? And so if GC is the ratio to CF, then to DB should be GD. So those are the parts that are matching up, right? So GC and GD and CF and DB. On the next one here, AF over FC, okay, so this part over this part, and then what over DB would be equal to it? What proportion would be equal to it? Well, again, if we're going AF over CF, then we would go BE over DB, or we could say EB to keep the letters the same if we went from A to F. E to B. And then we have CD, this length right here, over FB, and then GD over what? Now this one's a little trickier because FB is not just a part of the triangle, it is actually a whole side of this larger triangle right here. So FB is a ratio to CD and FB, and so GD is corresponding to which side in the larger triangle. So GD here, and so if we're talking about this larger triangle, then we would need to talk about GB. So GB is the corresponding side there. All right, the next one, we've got AE, this side, corresponding to CD, this side. And so GE would be corresponding to what? So let's kind of highlight again here. So we've got AE corresponding to CD. And so GE, the total length, would be corresponding to which length? And so if GE is on the larger triangle and we're going from the larger triangle to the smaller triangle, it would be GD. And then last one, FG is this side of this triangle over AG. So this side of the medium triangle over this side of the larger triangle. And so FB would be corresponding to the bottom side here, AE. So this is more about, can you identify those, the corresponding sides between there. It can be tricky with the overlapping. Number 2, lines L, M, and N are parallel, so find the value of x. Well, remember the parts of the overlapping triangles are proportional, and so we can approach this in terms of x divided by 2 is equal to 4.5 divided by 3. And so then I can solve this proportion. That'd be 3x is equal to 9, and so x is equal to 3. Now you can setting up that proportion is one way to approach it. Another way to approach it is, because we know that these sides, these different parts, should have a common ratio. If we take 3 divided by 2, that's 1.5. And so 2 times 1.5 gives me 3. So if I take this side times 1.5, that should give me this side. So I can do the same thing here. X times what gives me, times 1.5 should give me 4.5. So I just have to figure out what am I taking times 1.5 to get 4.5. So to do that, I just do 4.5 divided by 1.5, which is equal to 3. And so again, we see that here, x is equal to 3. So a couple different ways to approach it, either setting up the proportion like this to again recognize that, okay, this side over this side is the same as this side over that side, or that there is a relationship between the corresponding sides there, the corresponding parts. All right, number 3. AC is equal to 18. So that means this total length is 18, and AB, this total length, is 15. What's the value of x? Well, if we know that this total length is 18, and we know that this portion of it's 6, what is this portion going to be? 12. Okay? Now these are definitely not drawn to scale, right? That's 6, that's 12, that doesn't make any sense. Maybe it's better if the numbers are flipped here. But if that's 6, and this has to be 12 if the whole thing is 18. Well, because these parts are proportional to each other, you can think about it this way. 6 times what gives me 12? I times it by 2. That'll give me 12. And so you're taking whatever the length of this side is, whatever this side length is, and that will give you 12. Sorry, I was just thinking about something. So 6 times 2 is 12. And so what number times, what is x going to be? So if I can figure out what this side length is going to be. So I'm just trying to rethink how I did this and what would be the best way to explain it. Oh, okay, I remember now. So the relationship from this side length to the total length. Hey, what's the relationship from this side length to the total length? Well, that's times 3, right? If you take this side length, times it by 3, that would give you the total length. So again, because these different parts are proportional and these different sides are proportional, whatever this side length is times 3 would give me 15. So what number times 3 gives me 15? 5. So this is 5 because if I multiply it by 3, that gives me 15. And again, that's the relationship between the smaller and the smaller side here and the larger side of 18. So I now know that if this is 15 and this is 5, the whole thing is 15 and this is 5, then x has to be 10 here. Okay, so x is equal to 10. Sorry, I kind of lost my train of thought there, but the idea is that the relationship between this side and this side, the total length, is a factor of 3. 6 times 3 is 18. So that means if this side is 15, this whole length is, this must be 5, because 5 times 3 is 15. So we didn't actually really need the 12 down here, because once we figure out this is 5, 15 minus 5 is 10. Number 4, complete the similarity statement, then find SR and TY. So the similarity statement here is just recognizing what are the 3 overlapping triangles. So like the first one is ASK, and that's this one right here. And then the next one, again starting with ART, and then the next one ANY. So those are the 3 overlapping triangles. Now, if we want to figure out what SR and TY are, we're going to use that idea of proportional sides. Now, there's something in here that we've talked about a number of times, but it might be tricky to remember sometimes, is these are right triangles. And so we're going to use that fact to help us figure out one of the sides, because we actually don't have enough information here currently to figure out what the portions of it are, right? So we know that 6 times 3 is 18, so there's a relationship of 3 here. So 6 times 3 is 18. So that means if this is 8, then this whole length from A to N should be 24. But again, that doesn't help us specifically find SR or TY, so we need to do something else for us to do that. Because if we want to know what this whole length is too, we're going to have to figure out what this length AK is. And to do that, we'll use the Pythagorean theorem. Remember, the Pythagorean theorem is only for right triangles, where we take the 2 legs and we square them. So it'd be 64 plus 36, and that's 100. And then I'll square root this number. The square root of 100 is 10. And so that's the length of this, this side right here is 10. Okay? So again, just because it's a right triangle, I could use that Pythagorean theorem to figure out that that has a length of 10. Well, now I know that if this has a length of 10, and we already know that from the small triangle to the big triangle is a scale factor of 3, then I can just take 10 times 3, and that would be 30. And so this whole length from A to Y is 30. Well, if I know this is 10, this is 15, that's 25, and the whole thing is 30, so that means this is 5. So TY must be 5. And now, if I know I know enough proportions to figure out what SR is going to be as well. So I can set up this proportion. So if 8 to this SR side, which we'll just call X, should be equal to 10 over 15. So this side length over this side length should be equal to this side length over this segment here. So I'll take 8 times 15 and 10 times x, so that's 10x is equal to 120. Divide by 10, x is equal to 12, and so that's the length of SR, is 12 right here. So again, for that last one, SR, I just used the fact that the parts were proportional. So 8 over SR should be the same ratio as AK 10 over 15. So again, it's all about, can you identify which parts are corresponding to each other, and do you understand how to set up the proportions, like how they're going to relate to each other. So again, the different parts are proportional to each other, but also the different sides are proportional to each other.